All right, so in this module, we're going to go over an example, a series of questions in the quiz about determining the grain size from these micrographs. So let's start with the first question. So basically each one of these questions is to get you to sort of go through the entire process of calculating the grain size number. And so the first question, which again will be on the quiz as well, is we've got the micrograph here. It's a made up one, as you might imagine. And we have 7 different lines labeled for you. And what I want you to do is just pick one of those lines, so you don't have to go through all of them, but pick one of those lines and determine the number of grain boundary intercepts, like we did in the previous module, for your particular line. So calculate just for one of these lines. So pick whatever one, a random one, and see if you can determine the number of grain boundary intercepts, and then come back and we'll compare your answers. All right, so hopefully you've had a chance to look at the number of grain boundary intercepts for each of these lines, and I just want to make a quick note here that each line is going to be 50 millimeters for future questions. All right, so depending on which line number you picked, I'm giving you the number of grain boundary intercepts here. So you might recall in the previous module, we actually looked at grain number 7 and we counted up 7, right? So each one of these has 7, 8, or 9, and you can see that they're all the same length, but it does matter where you place the line in the orientation because we're getting slightly different numbers. And so that's important to get a large enough sampling on a particular image so that we get a certain number of grain boundary intercepts. And so this is critical. We don't talk much about the thresholds that are required, but in the ASTM that talks about the grain size number, you'll get numbers of how many grain boundary intercepts you have to have for it to be statistically relevant. All right, so let's move on to the next part of this as well then. So we counted up the grain boundary intercepts, and now what I want you to do is calculate the mean intercept length using the expressions that I've given you and using the information from the previous micrograph. So using that previous micrograph, using these equations, and using the data that we just did, calculate the mean intercept length. And so for this one, go ahead and use the sum. So use the total number and use the total length of that line from the total there. So calculate the mean intercept on the quiz and then come back and we will discuss. All right, so hopefully you've had a chance to look this over. So the first of all, the scale bar was given. It measures 17 millimeters, and then it gives you the, it says it's 100 microns. So using those numbers, we can calculate the magnification as 160. And then we're going to use our total length, which was the 50 millimeters times 7 lines. So that's where we get the total here. And then we count up all those intercepts, which was 58. So if we plug all that in, we get a mean intercept length of 0.0377. And these two are unitless. So this is millimeters. So the units are going to be millimeters here. So this basically tells us the average or mean length between the intercept positions that we have in the real material. So the conversion factor is the magnification. All right, so let's get to the last question then. So we've calculated the intercepts, the mean intercept length, and so now I'm going to ask you for the ASTM grain size number of this same material. So again, take what we just got and see if you can calculate the ASTM grain size number G for this material. All right, so you've had some time to do that. You've come back to the video, so let's go ahead and go over this. So the first thing is the selection of the equation. So if we go back, we see that this one is in millimeters, this one is inches. So we did everything in millimeters. So we're going to use that expression. And then we need to have, the only other thing we need to know is the mean intercept length, which was that 0.0377 millimeters from the previous example. And so plugging that all in, we get a value of grain size number of 6.16. And again, this is unitless when we talk about it, but this is the grain size number. This is something that we can compare from various microstructures and determine the relative size of the grains in a microstructure. So that's what this number is giving you. And again, I want you to think about relatively, how does this compare to a material that has a value of 1 or 10? And so think about those relative numbers and see if you can determine, which one has the larger grain size, which one has the smaller grain size.